The very first question is the multiple correct choice with one or more than one correct answer. The question is, let Z1 and Z2 be the complex numbers such that Z1 is not equal to Z2 and modulus of Z1 is equals to modulus of Z2. If Z1 has the positive real part and Z2 has the negative imaginary part, then Z1 plus Z2 by Z1 minus Z2 is always be option A is 0, option B is real and positive, option C is real and negative, option D is purely imaginary. To find out the solution of this problem, let us consider the given things in this way. Given is Z1 is not equal to Z2 and the modulus of Z1 is equals to modulus of Z2. And here real of Z1 is positive and imaginary of Z2 is negative. Then let us consider Z1 as A plus IB and Z2 as C minus ID for all B comma D are being the positive real numbers, so that the imaginary part of Z2 will be negative and the real part of Z1 will be positive. So here when Z1 magnitude is equals to Z2 implies it becomes A square plus B square is equals to C square plus D square. Let it be number 1. And for Z1 plus Z2 by Z1 minus Z2, if you consider this expression, then we'll get it as A plus C plus I into B minus D by A minus C plus I into B plus D. If I can rationalize this one, this becomes, if I multiply divide by its conjugate, A plus C plus I into B minus D by A minus C plus I into B plus D. When I multiply divide by the conjugate A minus C minus I into B plus D by A minus C minus I into B plus D, then the resultant will be is equals to A square minus C square plus B square minus D square minus of 2I into BC plus AD on simplification divided by A minus C whole square plus B plus D whole square. Further, Z1 plus Z2 by Z1 minus Z2 can be written as A square plus B square minus of C square plus D square minus 2I into BC plus AD divided by A minus C whole square plus B plus D whole square. But already we have A square plus C square is equals to B square plus D square. Therefore A square plus B square can be written as C square plus D square. Therefore this sum becomes 0. Finally Z1 plus Z2 by Z1 minus Z2 can be written as, this everything becomes 0, that is minus of I into 2 into BC plus AD by A minus C square plus B plus D square. This is purely imaginary. If at all Z1 plus Z2 by Z1 minus Z2 takes value 0, obviously the numerator should become 0. When Z1 plus Z2 that is equal to 0, obviously here the numerator, that is 2 into AD plus BC, can become 0. Implies AD plus BC becomes 0. Can be written as A by C is equals to minus B by D is equal to, say, some lambda. Let us consider it as some lambda. That implies when it is lambda, A can be is equal to C lambda, B can be equal to minus of D lambda. So when you take A plus Bi into consideration, it becomes lambda times of C minus Di. Where here Z1 can be written as lambda times of Z2. For all, if you take lambda equal to 1, Z1 is equals to Z2, which is a contradiction because Z1 can never be equal to Z2, since it is given that Z1 is not equal to Z2. Therefore, what we can conclude is lambda can never be equal to 1. That implies lambda can never be equal to 1 implies Z1 plus Z2 by Z1 minus Z2 never be equal to 0. And never be equal to 0, obviously only the option left with is Z1 plus Z2 by Z1 minus Z2. This can be only imaginary. Hence, we can conclude that, so this is purely imaginary and not 0. When it is not 0, when you go to the options here, this can never be equal to 0 and it can never be real and positive. It can be real and negative. So only the option left with is option D, that is, this is going to be purely imaginary. That is, option D is going to be the correct option for this question.